Do not get tricked by this biochemistry question.
It says that the physical properties of two proteins are shown in the table. And based on the information in this table, which technique would be best suited to separate the two proteins? So notice that protein 1 is a dimer, so it has a quaternary structure with a 40 kilodalton subunit and a 60 kilodalton subunit. And the subunits are held together by disulfide bonds. And the protein 2 is just a monomer, which is 100 kilodaltons. Now, first of all, protein 1 and protein 2, as long as protein 1 is in its quaternary structure, weigh the same. And also they have the same pi, which is the isoelectric point. So we could not separate them using isoelectric focusing because that depends on a difference in isoelectric point. So A is definitely incorrect. Okay. Now, when it comes to native page, right, this one also wouldn't work, right? Because native page, what would happen is you would run the two proteins down the gel, okay? And protein 1 would be in its quaternary structure, and protein 2, which is just a monomer, they both weigh the same in that situation, so they would travel the same distance. So this is also wrong. And then we have SDS page under non-reducing or reducing conditions. So non-reducing conditions would lead to the same result as native page. So we're left with D, which is reducing conditions. And this makes sense because if you added a reducing agent, right, you would be able to reduce these disulfide bonds holding together the quaternary structure. And so protein 1 would become two separate proteins, one that's 40 kilodaltons and one that's 60 kilodaltons. So those could be separated by virtue of their mass. And then protein 2 would remain as a monomer, right? And that would appear at the 100 kilodalton location on the gel. And then this protein would then basically form two separate proteins, and all of these would weigh different, all of them have different masses, so they would all be separated into three different bands, right? So D would be the best.